In section 3.1, we will be discussing quadratic functions. Let's begin with the standard form of a quadratic. That will look like f of x equals a times x minus h squared plus k, where a cannot be 0. The vertex of the parabola is going to be h comma k. In other words, flip the sign, keep the sign. When the a value is greater than 0, or a positive number, that means the parabola opens up. When a is less than 0, or when a is negative, that means the parabola opens down. To graph a parabola, we'll follow the following 5 steps. Determine whether the parabola is facing up or down. Find the vertex. Then next, find the x and y intercepts. And then finally, plot and draw your graph. Next, let's discuss the general form of a quadratic. And that looks like f of x equals ax squared plus bx plus c. In order to find the vertex when given general form, it's a little bit harder as standard form. So to find the vertex, we're going to use the formula negative b over 2a. And then in order to find the y value, you're going to plug in that value and find f of negative b over 2a. Next, let's discuss min and max. If a is greater than 0 or positive, then f has a minimum. But if a is less than 0 or if a is negative, then your function f has a maximum. Let's take a look at some examples next. If I have the function f of x equals to negative x minus 3 squared plus 9, let's find its graph. Again, my 5 steps are determine if the graph is up, down, find the vertex, find the x and y intercepts, and then we can plot and graph our parabola. Alright, so for this function, my leading coefficient, my a value, is negative 1. Since it is less than 0, that means my parabola is facing down. Step 2, my vertex, h comma k, is flip this sign, keep this sign. So it's positive 3 and positive 9 for the vertex. Next, we have to find the x and y intercepts. So let's do the x intercepts first. In order to find the x-intercept, I plug 0 into y. So it's 0 equals negative x minus 3 squared plus 9, and then we're going to solve for x. Subtracting 9 to both sides, I get negative 9 equals negative x minus 3 squared. Next, I need to take care of that outside negative or negative 1 by dividing both sides by negative 1. And I get positive 9 equals x minus 3 squared. Opposite of a square is a square root, so let's square root both sides. Square and square root cancel each other out. Remember, when you take the square root in the problem, it's going to have plus minus, and square root of 9 is 3 equals x minus 3. Alright, now we have 2 solutions, so let's remember to split that up into 2 parts. That's going to be positive 3 equals x minus 3, and negative 3 equals x minus 3. Solving for x, add 3 to both sides, and we get x equals 6, so there's one x-intercept. And again, over here on the right, let's add 3 to both sides. This time I get x equals 0 as my other x-intercept. Alright, let's find the y-intercept, and then we will be ready to graph. In order to find the y-intercept of this function, I need to plug 0 into x and solve for y. So, let's see, it was y equals negative x minus 3 squared plus 9, so I need to plug 0 in for x, so that's negative 0 minus 3 squared plus 9. And that's negative 3 squared plus 9. Negative 3 squared is positive 9, but because there's an outside negative, that guy is going to still be there. The negative will still be there. So negative 9 plus 9 is 0. Squish it in there. Perfect. So y-intercept 0. Alright, so let me come over here to the right as I've run out of space for the next example. Let's see if we can put all this information together. So I will see that my vertex is 3, 9, so that's to the right 3, up 9. There's a dot. I have an x-intercept at 0, and I have an x-intercept at 6. So we got another dot there, and my x and y-intercept are the same, so that's going through the origin. And I know my parabola is facing down again, which makes sense where the dots are. So starting at the vertex, we're just going to draw a round-shaped U through the points. And there is your graph. All right, let's try the next example. It says find the vertex of f of x equals x squared minus 2x plus 1. All right, this time my parabola is in general form, so I'm going to follow the formula negative b over 2a. So negative b over 2a. As a reminder, a, b, and c are your coefficients. So a is 1, b is negative 2, and c is 1. So formula has a negative, b is negative, so watch out for the signs. Divided by 2 times 1. So it's going to be positive 2 over positive 2, which is 1. So my x value is 1. Now after I find 1, I need to find f of negative b over 2a, which in this case is going to be f of 1. Plugging 1 into my formula, I'm going to get 1 squared minus 2 times 1 plus 1. Simplifying, I get 1 minus 2 plus 1. 1 minus 2 is negative 1 plus 1. I'm at 0. And so final answer, putting it together nice and pretty, your vertex happens at 1, 0. Next, a continuation with that same function. Let's find the range of f of x equals x squared minus 2x plus 1. Alright, it can help to draw. We don't necessarily have to draw it all out, but we do need to know the vertex. So we just found it in the previous example. Our vertex is 1, 0. Now let's figure out, is our parabola facing up or is it facing down? My a value in this problem is 1, which is greater than 0, which means our parabola is facing up. So without doing the entire 5-step process, let's just quickly do a graph of what this looks like. Its vertex is at 1, 0, so we're going to have a dot there. And we know our parabola is facing up, so I'm just going to kind of make up a sketch here. It's going to look something like this. I don't quite know where the y-intercept is, but that's not important. All I care about is where is the vertex and what is the shape of my parabola in order to find the range. Again, what does the range mean? The range represents the y values. So what is the smallest y can be and what is the biggest y can be? Well, the bottom of my graph happens at y value 0. It's a closed dot, so square bracket. And then my parabola is going up forever, so that's positive infinity.